Welcome to this video on how cryptocurrency actually works. We will explore the technical workings of Bitcoin, the biggest and most battle-tested cryptocurrency, to understand its core mechanics. It's not magic, just math and distributed systems. At its core, cryptocurrency is a decentralized digital ledger secured by cryptography. It functions without a central bank or server, as everyone holds a copy of the shared ledger. Crypto is essentially a distributed database secured by math. Cryptocurrency offers advantages like being decentralized, borderless, and transparent. However, it comes with trade-offs, including volatility, slower transaction speeds compared to services like Visa, and energy intensity in proof-of-work systems. It's a balanced system, not a perfect one. To understand Bitcoin, we must grasp four key concepts. First, the ledger is a transaction list stored by everyone. Second, a hash is a unique SHA-256 fingerprint of data. Third, the nonce is a number miners change to find different hashes. Fourth, proof of work is the computational effort required to find a valid hash below a target. Mining involves gathering transactions, building a block, adding a nonce, hashing the block, and checking if the hash meets the target. If not, the nonce changes, and the process repeats. Mining secures the ledger. It does not create money. The security of the blockchain comes from economic cost. To alter a single block, you must redo its proof of work and that of every subsequent block. This demands massive computational power, making an attack economically infeasible. We are about to demonstrate this using a local Bitcoin node. You will see a miner searching for a valid hash, a new block being successfully added to the ledger, and a small explorer showing the blockchain grow in real time. This demo uses the exact same mechanism as the global network, just on a smaller scale. During the demo, pay close attention to the hash rate and the number of attempts it takes to find a block. Once the block is found, notice how the ledger updates. This sequence captures the essence of mining.
What you're looking at here is a live Bitcoin node running locally on a private network, so we're not competing with the global hash rate. This is our wallet address. This shows the balance. Notice there's trusted and immature balance. When a miner finds a block, the reward isn't instantly spendable. It needs 100 confirmations before it becomes usable. That's how Bitcoin prevents reward abuse. Mining is just repeatedly hashing data with different nonces. A nonce is just a number we keep incrementing to try new hashes. The rule is simple. The hash must be lower than the target value. Every time you see this hash change, that's a double SHA-256 computation happening. On mainnet, miners do trillions of these per second using specialized hardware. Here we're doing it in Python, so it's tiny, but the logic is identical. There, we found a valid hash below the target. That means we earned the right to append a block to the ledger, and you can see the blockchain height just increased. That's consensus in action. The block reward halves roughly every 4 years. It started at 50 Bitcoins, now it's 3.125 on mainnet. Eventually, miners will only earn transaction fees. So to recap, ledger is shared. Hashing secures blocks. Nonce enables brute force. Proof of work creates economic security. Miners compete to secure the network. It's not magic. It's math plus incentives.